Hello, welcome back to the channel. This is going to be part 2 of my TM990 repair upgrade series. If you want to skip ahead to the repair, I'll leave a link which will be upgrading a few components. I'm just going to, for this first part though, if you do want to skip it, go ahead, but for this first part I've not really told you about this machine, so we're going to dig into this a little bit further and see what it was all about, what its purpose was, and then we're going to enter a program into it. It's kind of like the Hello World program. So if you're not aware, every programming language out there has a Hello World program where you print Hello World on a screen. In the world of Arduino and other microcontrollers, that would be blinking an LED or changing the state of an output. On this one it's no different, so we've got the 4 LEDs down the bottom. We're going to be blinking one of those, so that's the simple hello world of this. So I've snapped a page out of the manual. I'll show you that program, then we'll enter the program onto this thing with its weird calculator keypad entry thingy. It's all very odd. Yeah, and you'll see how this thing was programmed, so we'll dig into that in a bit more detail. Then we'll go on to the upgrades. I'm going to upgrade this to the University Basic Standard. Now, it will be completely reversible. Anything I do to this would have been available off the shelf, apart from the EEPROM upgrades. I'll go into that in a bit more detail as well. But my reasoning for this is being donated to a museum. It's being donated to the Plymouth University Computing Museum. So it kind of ties in that this would be University Basic Standard. They would have programmed these things through a serial terminal. Back in this kind of era, you would often program on a teletype terminal. So you'd have a keyboard and a printer, or a green screen if you had the luxury of the green screen. So these would be programmed through a serial interface. So that's what I'm going to try and do. Now the ROMs for this, strangely coming off one of the MAME sites, Multi-Arcade Machine Emulator, freely available. I can't tell you where, YouTube rules, but yeah, so that's where I'll get the ROMs from to update this thing. Yeah, let's get on to the programming, show you a bit more about this. Right, so here we are back with the board, all powered up with our lovely 4 LEDs working nicely. I'm just going to work through this program. So we start this by pressing return, and then we enter the command M for memory inspector, and we're going to go to pointer position 200 in hex and return, and that now shows us what's currently in that memory position. So on there we have OE1F. So we're going to start entering our program, and I'll go into super speed mode on this, but we'll start with O2EO SP goes to the next position. This one is O300. Right, we're all done, and now we can just go back to the memory inspector. Doesn't always go this time. There we go. We just iterate through and check is it's right. So 020, 300, O2IC, 20, 1DOO, 0201, 882, 0601, 16FE, 1EOO, 0201, 8P82, 0601, 16FE, 10F5. Return. Right. So now we set the program pointer P to 200. Return. And we execute with E. E, where are you? E. Blinky blinky. So that's our little Hello World program. reset, and you can go back into your so then we press the load key and it's all still there, so we can go in and change it and do what we will. We just go back to 100, execute, doink, blinky blinky. So yeah, quite nice. But as you can imagine, if you're doing a long program, this would get pretty tedious. So we've just done a very simple one there, just to blink an LED. I think my dad's assignment is the same when I did computing at uni. We had to do traffic lights in machine code. I think we did in Pascal actually at uni. But yeah, I've done it in machine code as well. So you just do a traffic light system with simple delays. So no intelligence, just simple delays. In a PC we use the printer port, which you don't get anymore. You need a card, I think, to do those, or USB maybe. I think you can do it in DOS. But anyway, yeah, traffic lights program, in this case, blink an LED. So you can kind of see the purpose of it. So you can inspect memory locations. You can see your code in there, iterate through. Of course, this is in pure hexadecimal, so there's no what do they call them, mnemonics to go by. So normally you would have mnemonics, so we'd like JMP, like jump command, things like that, and that would be represented by a hexadecimal code. In this case, they do have the mnemonics in the manual, as you see on the other page, and they are just represented by these codes. So we'll have a look at the University Basic upgrade, see what we can do with that. As also this funny port up here, that was used. I remember my dad modified a tape deck so we could use that. You can save your programs to tape, so we're going to have a go at that as well, but I probably won't use tape. I'll just record it into a sound card and then we can see if we can play it back and load it. I think it'll be quite interesting. So for now I will drop this and I'll go over to the upgrades. So welcome back. If you skipped the other part, yeah, please watch it if you did skip it. It's quite interesting. Gets a bit technical, but I do tend to do that, so apologies. We're going to move on to the upgrade portion, which will be adding components to this area up here to enable the use of this port. And it doesn't just work straight out of the box. You need a communications control chip and you need to change the ROM. So with this one, first thing I'm going to do, power down of course, I'm going to take this ROM out and read it so we've got a good copy. Do not want to lose that. So yeah, make a copy. We need more RAM, so it's changing these so you can put more RAM in there on board. They need to all be the same ideally, so take these out and swap them. Got a bunch of DRAM chips. I don't have a tester for those unfortunately, so I'll have to put those in and see if they function. So first of all, first thing I do is swap these out. So take a copy of that, then swap these out. I've been farting around off camera for well over an hour now. It appears I have some dead RAM chips. I knocked up this SRAM tester. I'll show you that very quickly on screen. I pulled one of the good chips out of our board and popped it in. All tests fine, and the ones which I got, I think they're off eBay, they're all testing open circuit, so they are plastic with metal legs sticking out. So I'm going to do a YouTube short on what to do with those. I think you'll find it quite amusing. What that will mean is I need to order some more 2114s. Thanks to the wonderful communities on Facebook, I've managed to find a reputable source for them. They do cost significantly more, but I'm not too worried about that. It's not going to break the bank. So I'll get those in as soon as possible, and we'll upgrade the RAM later on. It'll probably be tacked on to the end of this video now by the time those turn up. Back with the board. Right, number one. Back up this chip before I go any further. So let's go lever that one out. I shall pop that into the programmer and read its contents. Well, change of plan it seems. The 4732 is not supported by XG Pro or any of its successors, that's the word. So it looks like we're going to have to make a chip adapter project. Here I've got the two data sheets. On the left the TMS 4732 which we want to read, and on the right TMS 2732A which we do have specified in the programmer. So what I need to do is translate this pin out over to this pin out on the right. And so it looks like all we're going to do is take pin 18 and move it over to pin 21, and our enable pin 20 we'll move that on to 18. They've also got 21, so we could either tie that with 20 or it may need to be separated. So we're going to build a breadboard adapter for this. So this S1 not S1, S2 not S2 business going on here, this can be programmed into the chip what these do, whether they are high for enable or low for enable, and it could be a combination of any of those. So we'll leave the option where we can tie them to ground or up to VCC in order to make the chip read. That's what we shall do. I'm going to lash this out in EasyEDA and just build just a simple circuit. It helps it in my mind just to visualize it, otherwise I tend to get a bit mixed up. So I'll get on and do that next. So this is the circuit I've got in EasyEDA. At the moment I've just tied those two select pins together. So the nearest equivalent I could find in here as well was 2532. It's the same pin as the 4732 near enough. And there's the the layout on the programmer. That's what we're going to try and mimic. So if I draw it out, it's easier in my head, and then I can just quickly transfer it to PCB mode. And I've got one chip over the other, and I can just see which ones to connect. It's just for my head. It's the way my head works. It helps if I can see it and just highlight pins like this and see where the nets go. So let's get on and make this adapter, and then we can read our chip. I just put pin 1 in there and just gently squidge him in. There we go. A much better idea. I can just droop onto it straight across into here. So now we should be able to read our chip. So we just got a crossover on a couple of pins, and there's one blank, of course, we're not passing through that one. Right, let's give him a shot and try and read the chip. Right folks, we're back. That's a good job I did breadboard this out, because on the datasheet you've got S1, well, not S1, S1, or not S2, S2, and down here on chip select, so either or can be active high or low depending on how it's been programmed. So I've had to jiggle around with wires and find the right combination. It just so turns out that 21 needs to be high and 20 needs to be low. So that's how they've done it. And I've got him in the programmer now. So I'm just going to hit read. So I'm saying 2732, it's the right size and kind of type. And now we've jiggled the pins around. Doink. Ignore. Ta-da! Data. And there it is. We have a copy of our ROM. If I just go to the middle point, which should be 7FFFF. So we just look for a repeating pattern. Luckily we do not have, otherwise that would mean it wouldn't be getting the addressing correct. So yep, it's all there by the looks of it. And it's programmed almost right to the very end. So there's just a few left with FF blank in there. Not sure what that is there, might be a checksum. Yeah, so there it is. So there's the human readable part. And now we can save that. Right, so I'll save that. I'll save its bin. Browse. So yeah, I've got a location there. I'll build it U33 original. And I'm going to save that one. Ta-da! So we have the copy of our ROM. Right, back again. ROM is back in for now. I've just fired it up and tested it. I'm going to get rid of this arrangement going up to my PC power supply up there. I've got a connector for it. I won't go into this in too much depth because I'm going to do a separate video on power supply. I'm going to try and make a new replica one. But for now, instead of all these, some of these wires are a bit short. Instead of having these wires trailing everywhere, I'm just going to knock up this. Okay folks, I've got the Bible open. I'm going to do the Async Comms RS232 upgrade, and if we go on to the next page, let's move that down into view. We're going to be installing these components. So it's a 9902, a 1488, whatever that is. I think it's a 74, one of the 74 chips. I'll have a look. Then we've got some resistors to install, so a 10k, 2 3k3s, and then a 25-way connector. Right, we're just going to remove the solder from the ones we need to. Let me just check. 3, 4, 3, 5, and 3, 6. So 3, 4, 3, 5, and 3, 6. So 3, 4, 5, and 6. That's these three here. Group of 3. I'm going to do the RS232 mod, not the TTY mod. That's for the old 20 milliamp current loop devices, which would mean populating this Q12 transistor and loads of other stuff. I'm just going to be using RS232 into a serial port. I'm not going to be driving printers or green screens or anything with this, so I'll do that. I'll just clear out those holes. Ready for our components. All clear. and get these components in. So 10k goes into 3/4. And I tried to get these reasonably period correct resistors, not quite the same, a bit of a lighter shade of brown, a bit larger, but they will fit a treat in there. There, nice. And which way have they put the bands? So they've got the bands facing that way. I'm going to copy it. Nice to be consistent. Our solder blobs off here as well. I'll pick those off with the tweezers in a sec. I'm just going to put these in place. I just nip these off. And next, soldering this one. So this I managed to find, it's the same port they used on the original. A perfect match. That one goes in there. Like that. So I'm just going to flood the end of my iron with solder, and then it's going to hold the port in nice and flush, and then I'll tack it so it stays exactly where we want it. It's good enough for a tack around on there. Need a bit more than that. It's staying put at the minute. So just while that's liquid, let's give it a little push. That's tacked. I'll solder those up properly. There we go, that's all the solder components in place. So I'll just give the board a quick clean and we can push the chips in. So we've got our 3 resistors in place, and it's got to populate that one and that one. So it is, let's check the Buke. So 37 is the 1488 they call it. It's a, oops, dropped it. Also known as a 75188 quad line driver chip. That goes in U37, and I believe that's the, which is the pin 1 designator. There it is. There's a little 1 on the board just down here, designates pin 1, so that goes in that way. Like that. Good check, those two soldered together there. Stick on that side of the board, so they're common. So those top 2 are common. Yeah, there's nothing soldered wonky there. And the 9902 doink goes in here. Need to get out of this sellotape. So he's on 9902. ANL, this one apparently week 39 of 1988, made in the Philippines. So assuming that's true, this isn't fake, that pops in there in U31. Pin one down there. Like that. And now we should be serial port capable if all gone to plan. So I'll do a quick diode test across here, make sure I haven't soldered anything together that shouldn't be, and power him up. I've got my little helpers today. Okay, we're back with board. Everything powers up nicely. I've had a little check, nothing's getting warm. It's all nice. And let's turn that off. We're off. And I've got 25 to 9 way and a USB serial adapter. So I'm going to plug this in. I'm just going to see if anything comes out of here at all without us programming it. It'd be nice to see if it does. We're all connected up, and if you power it up, it's got real time here. This is a serial capture program you can freely available. I think it's on SourceForge. I just fire up the board. It's currently just sending out a null. I imagine it needs to be programmed to do something. I think it's just going to work out of the box. If we have the University Basic ROMs in there, I think it does chuck something out of the port. So that will be our next step. I'm awaiting RAM chips still, as our other ones were dodgy, fake ones from eBay. So I'm waiting for those, and I'll program up the ROMs then and get them in. Hi folks, it's a week later, and good news, some chips turned up in the post. So yeah, courtesy of Silicon Arc, no affiliation, but I just thought I'd give them a mention because they've provided me with chips that work. I'll plug the tester in, you can see it. And I'll pop the link to this tester in the description as well. And there we go. So let's get these in the board. And we got our chips here. So I had to get, I think they're Microchip or National Semiconductor, I can't remember which. I can't remember what that logo is, I think it's Microchip. I'm just going to pop 2 of these in, pin 1, bottom right corner as we're looking at it. So I had originally these off of eBay, which claim to be many C2114s. They just test open circuit, as you've seen. A load of rubbish. But yeah. These ones do the job quite nicely. Expand our RAM. I'll check the manual. I don't know if you have to do any jumper changes to enable the extra memory. There's our power connector again. Plug him in. And hit the switch on the wall. That one. And it's that one. Yep, all good. Fired up nicely. So I'll go away and check the book and just see if we need to do anything to enable those. So now we've got working RAM chips, we can expand the ROM area and hopefully get University Basic on it. So that's it for the main board modifications. We've got our RAM in, we've got our port components in, it looks like it's working. So our next video will be the EEPROM parts. That's building up U33, U32 and getting University Basic on it. So yep, I look forward to seeing you all on that one. Let me know in the comments if you've got any suggestions, things you might have done better, things that look good, etc. It's all really appreciated. And if you do like this, please like and subscribe, spread the word. Thanks very much. See you next time.